we go. So my picture is folded like we're going to, we are going to start with the front side. Mine is folded in half. Yes, I see that it's not working. I love our internet services. Okay, here we go. All right. So today we're talking about the angles that are formed by secants and tangents. So we probably need to know what a secant and a tangent is. So the first theorem that I'm going to talk to you about is this theorem right here. If a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is half of the measure of its intercepted arc. So let's talk about this. A secant, we did this on a sorting activity, is a line similar to a chord. Do you guys remember when we did that sorting activity with pieces of a circle? So a secant is similar to a chord. Michael, you with me? Do you want me to come sit over there by you? Okay. All right. So this would be the secant right here. So a chord is just a line segment. A secant is a line or a ray. So that means that the tangent, which is a line that just touches the edge of the circle. It just touches the edge of the circle. So this is our tangent. So when a secant and a tangent meet at the point of tangency, that's this guy right here, point of tangency. When they meet at the point of tangency, the formula for the angle, or the way that we figure out the measure of the angle, we're going to call it x degrees. So the measure of angle x equals half of the arc. So this is my arc. How do we feel about that? You feel good about it? Okay. The next theorem, the one right across from it, so I'm going to go straight across the paper, says if two secants intersect in the interior of a circle, and remember mine's folded. When I scanned it, it's folded, so I cut off some of the words. But if they intersect in the interior of a circle, then the measure of the angle formed is half of the sum of the measures of the arcs that are intercepted by the angle and its vertical angle. So let's talk about that. So I have two secants, two lines that intersect inside of a circle. So the measure of the angle, we'll call it x, on the inside. Well, first of all, you notice that if this is x right here, this side is also x. Why? They're vertical angles, and we know that vertical angles are congruent. So the measure of angle x equals half of the measure of the small arc plus the larger arc, or just the two intercepted arcs. So we're going to call it arc 1 plus arc 2. So I just labeled those A1 and A2. I don't know if you can see that or not, so I'm going to make it nice and big. These actually say A1 like A for arc, A1 and A2. It just keeps getting sloppier as I write on it. Okay, so those are my little arcs. So we have the first theorem is about a secant and a tangent. Our second theorem is about two secants. And our third theorem is about two secants, a secant, and a tangent, or two tangents. If they intersect in the exterior of the circle, are you good with that? Everybody good with this? I can go down? So if we have two lines, whether they're tangents or secants, if they intersect in the exterior of the circle, it always looks like an eyeball picture to me, then the measure of the angle formed is half of the difference of the measure of the intercepted arcs. So we're going to call this angle right here. And when I think about my intercepted arcs, I have this arc right here. We're going to call it A1. And I also have this arc right here. And we're going to call it A2. Now, I know you don't see it, but these arcs actually like kind of touch each other, right? Because that, I mean, if it's a point of tangency, if these are tangents, it's going to be all of the measures of the angles, right? So this just says that the measure of angle X equals 1/2 of the larger arc minus the smaller arc. I might need to write that. Larger minus the smaller. Because if you do the smaller minus the larger, you're going to end up with a negative, and you can't have a negative angle measure. Okay? So we're just going to do some fabulous practice with that. Are we all good? Okay, so flip it open onto the inside. Maybe I'm lost. Here we go. Example number 1. Example number 1 asks us to find the value of x. This is a tangent, and this is a secant. So this is theorem number what? Yeah, this is the first theorem that we learned. This is the first theorem that we learned. So remember that the measure of the angle equals half of the measure of the arc. So what is the measure of the angle? 89. So 89 equals half of the measure of the arc. And the measure of the arc is 1/2 parenthesis 22x plus 4 degrees. That's crazy. No. They did not already add the half. Okay, so I'm going to start with the innermost parenthesis, because that's what order of operations says we have to do, right? I'm going to take my innermost parenthesis, and I'm going to simplify that. So I have 89 equals 1/2 times, what is half of 22? 11, so 11x, plus half of 4 is 2. Okay, so I can do the next parenthesis, right? I can take care of the next parenthesis with distribution. Or what could I do to get rid of that fraction? Multiply both sides by 2. Multiplying by 2 gets rid of a fraction, right? Multiplying by the denominator. So half of 2 is 1. This cancels out our fraction. Do you guys see that? And 2 times 89 is 100 and, let's see, 90, 180, so 178. 178 equals 11x plus 2. 178 equals 11x
Misha said
plus
she wasn't here yesterday, so she said she don't have one of those.
Right, it's in the
She
folder
will.
with her.
It was just Gio and Dariana that gave me one for.
I believe that she did one.
Well, I was surprised because there was no notes or nothing with her name on it, so.
Yeah,
But you have a spot where it should have been her grade or whatever.
that doesn't have a grade on it.
Doesn't have any kind of thing on it.
So
It's
I
empty.
went by the absence.
'Cause you put
list that he
A
gave
for
me.
one and ALC for somebody and then there was.
He
just-
did that,
oh.
so she needs one. Okay. Thank you so
Thank
much.
you.
I just went off of what he had said for absent or, you know what I
Okay.
mean? Thank you, ma'am. Okay, so what do we do now? Subtract 2 from both sides. So 176 equals 11x, which means x equals what? Yeah, divide both sides by 11. 16 equals x. Are we good with that? Yes, no, maybe so? Max, you with me? Okay, pick your head up for me, sir. Okay, this is 2 secants intersecting inside of a circle. Kind of looks like a bow tie. So remember, we know that the measure of the angle equals 1/2 of arc 1 plus arc 2. So x, that's the angle, equals 1/2. What are the measures of my arcs? Yeah, 85 plus 35. So what is 85 plus 35? And half of 120 is, so 60 degrees. X equals 60 degrees. All right, I'm going to move over to the next one. I got it frozen. So let's look at the next one. The next one I have what kind of lines are those? Tell me what those 2 lines are. On example 3. One is one is a secant and one is a tangent. I have a tangent on the outside. And this one that goes through the circle is a secant. Okay? So I know that the measure of the angle equals 1/2 of the large arc minus the small arc. And I know that because the angle is made outside of the circle. So the measure of the angle, well, my angle is x plus 25 equals 1/2 of the large arc. Well, the measure of the large arc is, looks like the measure of the large arc is 4x plus 5, right? Minus the measure of the small arc, which is 50. Well, the first thing I'm going to do is multiply both sides by what? I want to get rid of this fraction. Large arc and small arc, yeah. Like LG arc, SM arc. So I'm going to multiply both sides by 2. That eliminates this fraction. 2 times x is 2x. 2 times 25 is 50 equals 4x minus a positive 5 and a negative 50 is a negative 45. What do you want to do next? Subtract what? You want to add 45 to both sides? Is that what you said? Sure, I'm down with that. Add 45 to both sides. So that gives me 2x plus 95 equals 4x. Who else has an idea? Subtract 2x from both sides. So 95 equals 2x. Divide both sides by 2, and I find out that x equals 47.5 degrees. Okay. How do we feel about that? That's just using those theorems, okay? So here we have an inscribed polygon, I know I've got the screen frozen, but I'm going to still talk through this. So we learned something yesterday about an inscribed polygon. What did we learn? That's if you have so if you have an inscribed angle, the measure of the inscribed angle is half of the arc it intercepts. But we learned something specific about polygons yesterday, something about their angles and opposite each other. I would look at my theorem from yesterday. Look at this page right here. Theorem number 4 from lesson 6.41, your journal yesterday. Theorem number 4. Opposite angles are supplementary. Opposite angles are supplementary. Okay, so let's see. It says in the figure, quadrilateral NEWL is inscribed in the circle. And remember what inscribed means? Inscribed means that the vertices of the quadrilateral lie on the edge of the circle. Okay? So TR, this segment, is tangent to circle K at E. And the measure of angle in LW is 78. So this angle right here is 78 degrees. The measure of arc EN, this arc right here, is 46 degrees. And LN is congruent to WE. Segment LN is congruent to segment WE. Find each measure. How are we going to go about that? Why do you think WN is 78 degrees? Oh, why do you think arc WEN or angle WEN is 78? Because 78 plus 78 is 180? Mm-mm. What do we know about, what do we know about angle WEN? It's supplementary to its opposite side, so what is the measure of WEN? It's 102. Nice recovery. Okay, I'm just going to talk about this for a second. If this is 46, let's look at this angle. Angle NLW intercepts this whole arc right here. So you kept telling me that the angle is half of the arc, right? Isn't that what you guys kept telling me? So the angle 78 equals half of the arc it intercepts. Okay, well, I know that one of the measures of the arc, like, because that's broken up, is what? 46 plus, what do we want to call that other side? Call it what? I don't want the answer. Let's just call this x for a second. So half of 46 plus x. So what are we going to do? Well, we're going to multiply both sides by 2. So 156 equals 46 plus x. So 110 equals x. So this arc has a measure of 110 degrees. I think that's one of our questions, the measure of arc EW. It's 110 degrees. We know that this is 102 degrees because they're supplementary. Could we figure out the measure of this angle right here? Do we have enough information?
Wait, we already have another answer, don't we?
Which one?
WEN?
WEN, yeah, 102. Yes, sir. Do we have enough information to figure out that little highlighted blue angle, angle N? What do we know about congruent chords? Congruent chords cut off congruent what? Congruent chords. Do you guys see that I have 2 congruent chords? This chord is congruent to that chord right there. So what does it mean about their arcs? Yeah, the arcs that they intercept are congruent to each other. So if the arc on the right is 110 degrees, what is the arc on the left? It's also 110 degrees. So look at what I'm trying to show you. This arc right here has to be congruent to this arc because they have congruent chords. They're created by congruent chords. So this is 110 degrees also. So can we find the measure of angle? Well, we'll get to TEN in a second. WER. How do we find the measure of angle WER? This is angle, oh, yeah, we're not trying to figure out this angle at all, WEN. We already know it. I mean, the arc measure. I thought we were trying to figure this out. Never mind. Okay, yes, easy stuff. Angle TEN. How do we do that? Go ahead.
180 minus 102 minus 46 equals W. It's on a 180, right?
It is a straight line. So 180 minus 102 minus what? Yeah. So what do we know about the degree of the arc compared to the degree of the angle? It's half. So if arc EN is 46 degrees, what is the measure of angle TEN? It's 23 degrees. And if arc EW is 110 degrees, what is the measure of angle WER? 55.